Hello everyone, welcome back to Farcon Technologies. Another day, another video, as you already know. And so in today's video we'll be doing the skills integration challenge, packet tracer. I have not done one of these before, during my studies for the CCNA. So that should be interesting. So let's go ahead and get straight into this here. So the router central, ISP cluster, and the web server are completely configured. You must create a new Ipv4 addressing scheme that will accommodate for subnets using the 192.168.0.0/24 network. The IT department needs 25 hosts. The sales 50 hosts, and the staff requires 100 hosts. And there's going to be a future subnet that will be added, and that needs to accommodate 25 hosts. You must also finish the basic security settings and interface configuration on R1. Then you will configure the SVI interface and basic security settings on switch 1, switch 2, and switch 3. Okay, alrighty, so let's start with this Ipv4 addressing. Use the 192.168.0.0/24 to create subnets that meet the host requirement. Staff 100, sales 50, IT 25, guest network to be added 25. Okay. I have actually gone ahead and done this already. So let's go ahead and have a look at this. So we're told that we get this network address, and we need to subnet it to accommodate for 4 subnets with each of the subnets having different host requirements. So let's see. So obviously, just going off of the /24, the first 3 octets are going to be the network bits. Therefore, I marked them in red. The last octet is going to be the host bits. And that's why I also wrote down the subnet mask, right? And that's why I always wrote down the last octet of the subnet mask in binary. So, but however, as a /24, I was just doing a little bit of subnetting. That's why I changed up the bits. So let's go ahead and change it back to 3 zeros. Okay, alrighty. So with subnetting, you always want to start with the subnet that requires the most number of hosts, right? So in our case, it's a staff network. So it requires 100 hosts, right? So how many bits do we need to borrow to get 100 to get a subnet that will give us 100 hosts? So if we borrow 1 bit, we're left with 7 host bits, right? So 2 in the power of 7 gives us 128 actual IP addresses. However, this 128 includes the network and the broadcast, which we're not going to use on any of the hosts. So we take away 2, which gives us 126 usable IP addresses. Okay, so our subnet mask turns into a /25 because we borrowed 1 bit, right? So the network address is going to be 192.168.0.0. Just take this one. The first usable, we just add 1 to the last octet, which is this one right here. Okay. Then to find the last usable, we take the 126 that we got here and we add it to the host octet, host portion of the network address, and we get the last usable, which is 126. And to get the broadcast, we just add 1 to the host portion of the last usable, and we get 127. You might have noticed that I typed down here even odd, right? And that is right. So 99.9% of the time, what I noticed and what I was actually initially told, right, is that the network address is always going to be an even number. The first usable is going to be odd, as you can see, even, odd, and then the last one is going to be even. Last usable is going to be even, so 126, even, 127, odd again. All right, so that is just a little bit of a trick, I would say, just to make sure that you're on the right track. Again, it doesn't work. It might not work all the time. I personally have not had a time where it did not work for me, but there could be. It's not an official method of determining if you're on the right track, but 99.9% of the time it does work. So yeah, so this is gonna be our staff subnet right here. Let's go ahead and start working on our sales subnet. So as you can see here, to get the next network address, for the next subnet, we just add 1 to the broadcast, or we add 128 to the network address of the previous subnet, and we get the same thing. So either way it works. So again, now we need 50 hosts, right? If we go with the same subnet mask, we're just going to waste addresses, obviously. So let's go ahead and see how many are we gonna get if we borrow 1 more bit. So now we have 6 host bits left. Turn this to 6. This will give us 64 actual and 62 usable IP addresses. Now, if we borrowed 1 more bit, that would give us 32 actual, which is not enough for the sales. So, and if we went with the same mask as for the staff subnet, we will be wasting addresses. So we need to meet in the middle and borrow 1 more bit and have 6 host bits to give us 62 usable IP addresses. So as you can see, we just add, so the subnet mask, the subnet prefix changes to /26, obviously. So for the first usable, it's going to be, you just add 1 to 128 to your network, to the host portion of the network, and you get 129. The last usable, we take 62, add it to the host portion of, or we add it to the last octet of the network address, and we get this number right here, so 190. And then to get the broadcast, again, we add 1 to the last usable, get 191. And as you can see here it also does this thing where it's even here, it's odd here, it's even here, it's odd here. So like I said, 99.9% of the time, this trick should work for you. Let's move on actually. So the 25 hosts for IT. So we add one here to get the network address of the next subnet, or we could also just add 64 to the network address of the previous subnet and get the same address like I mentioned previously. And now we need 25 hosts. So now we can go ahead and actually do what I was talking about earlier, order 1 bit, and then we're left with 5 host bits, which gives us 32 actual and 30 usable IP addresses, which is just enough, right? We have a room for growth for like 5 more addresses here. So the prefix changes to /27. Obviously, you add 1 to the network, you get 193 for the first usable. You add 30 to the network portion, to the network address, and you get 222, which is the last usable. You add 1 to that, and you get the broadcast, which is 223. And as you can see here, even odd, even odd. For guest network, it's not going to change, obviously, because we still need 25 hosts. So we add 1 to here, right? And let's write down the subnet prefix here. So yeah, we add 1 here, 224. We add 1 more. We add one here, one to here. We get the first usable for this subnet. Then we still add the 30 because the subnet mask or the prefix has not changed, and we add 30 to the network address. We get 254 for the last usable, and the broadcast is going to be 255 by adding 1 and then getting 255. So yeah, that is your subnetting portion of this exercise. And I went ahead and actually filled out the table here. I assigned the first usable addresses of each subnet to the router ports that they're connected to. So for example, 192.168.0.1, port 000 is connected to the staff network. So I assigned the first usable, and accordingly I did the same thing for all the other ports that the subnets are connected to. For the central, I didn't do anything because obviously it's configured. S1, I went ahead and assigned the second usable. Okay, so let me go ahead and change that here, 02, and then let's go ahead and copy this and just kind of, there we go. Alright, so this is what is going to be what is going to happen for the switch 1, switch 2, switch 3 SVIs, switch virtual interfaces. And for our PCs, I believed I assigned the last usable, yes. So for the PCs, I assigned the last usable addresses to the PCs. And the web server is obviously configured, so okay. Alright, so PC configuration. Configure the assigned Ipv4 address, subnet mask, and default gateway on the staff, sales, and IT PCs using your addressing scheme. Assign IPv6 unicast and link local addresses and default gateway to staff, sales, and networks according to the addressing scheme. Okay. let's go ahead and do just that. Alrighty, so let's go ahead and just configure our PCs here. Sorry about the background noise. It's a little bit cold out here, so I just turned on my heater. Let's go ahead and do 192.168.0.2 actually. Oh wait, no, 126. 126. Subnet mask. I think for the staff it was 25, right? Is that what it was? Yeah, 25. 128. Default gateway is gonna be 192.168.0.1. Perfect. So that's our staff, and then also we need to configure the IP address here. Let's go ahead and that's /64. Okay, and okay, alright, we need to configure the link local as well apparently, because this link local, as you can see by the FF and FE, is configured by using the host portion of this link local is configured by using something that's called EUI64 method of IPv6 address creation. You can check out the video on this specific method on my channel as well. I go into pretty good details as far as the EUI64. Okay, so default gateway needs to be configured as well. Let's go ahead and see. Okay, it's going to be literally the same thing, but with that one. Okay, alright, so that's our staff PC. Okay, completion 7, perfect. Alright, so let's go ahead and move on to sales. So for sales, we have 190. Okay, subnet mask. I believe it was /26, so that is going to be 128 plus 64, which is 192. The default gateway for this network is going to be 129. Right? Yeah, right. Alright, so okay, alright, so that we're on sales, so we need to configure what happened. Invalid default gateway. Why? 92.168.0.129. How's that? Okay. Something must have happened there. Anyways, so this is gonna be our. Oh, I did a mistake. I made a mistake. So the default gateway is actually supposed to be FE. Oh wait, so that's the link local. Oh yeah, we need to change the default gateway to this. Yep, cool. Cool. Alrighty. So let's go back to sales. 192.168.0. Okay, got it. This is gonna be our global unicast. You can tell by the 2001 global unicast usually starts with 2001 or 3. Well, it starts with a 2 or a 3, I should say. So let's go ahead. Alright. So the link local is going to be FE82. And the default gateway is going to be FE80::1. Oh my god, seriously, come on. FE80:1. Perfect. Alright, so now for the IPv6 or IT, sorry, so we're gonna do this one, and then that is a /27, so it's gonna be 224. Default gateway, let's see, pretty sure it's 192. Yeah, 192. Wait. Huh? Hold up. Give me 1 second. Oh, okay. Alright, so I made a mistake. I was not supposed to do that. Alright, so we are gonna change that to 22. We're gonna change it to 2222. So not sure how that happened, but hey, it's IT. And 193 is actually supposed to be the default gateway. Yes, so this is actually going to be the default gateway. And then as far as the IPv6 is concerned, it's going to be this one right here, /64. The link local is still going to be FE80::2. Alright, and the default gateway is going to be FE80::1. Cool. So our hosts are configured now, so that's good. Let's now move on to the R1 configuration. Alright, so let me pull up my document here as well. Alright, so let's go ahead and actually, first of all, configure the basics on the router before we go ahead and configure the IPs. So let's go ahead and show IP interface brave to see which interface is already configured. Okay, so the interface going out to the central is already configured, so that is good. And it's an up. Everything is administratively down, so we need to bring that up. Configure the device name according to the addressing table, and that is going to be hosting R1. Okay. Disable DNS lookup, so no IP domain lookup. Okay, and so disabling the DNS lookup, it's pretty much done. So for example, if I accidentally type in, instead of conft, I type in conf, you know, and it's gonna try, the router by default is gonna try to resolve that into an IP address, because it's gonna think that it's a host, or it's a site that needs to be resolved into an IP address. And then it will take a while to do so. If you don't know how to get out of that process of lookup, it's going to be stuck on that screen for 2 or 3 minutes, maybe even more sometimes. So it's better just to disable it. So encrypted privilege exec mode password. So we're going to go ahead and enable secret Cisco ENPA 55. Okay, and then on the okay, sorry about that. I just had to answer the call. So now we're gonna go ahead and assign Cisco co-NPA 55 as the console password and enable login. So line console 0. Password Cisco co-NPA 55. And just as a reminder for you and for myself, these Cisco, when you set a password with a password command, it's not going to be encrypted. So we're going to need to encrypt that later on. But for now, Cisco NPA 55, we'll do login to tell the line console to log anyone that can input this password or that knows this password. Logging synchronous to, for example, when there's like a pop-up message, right? Like, for example, we're waiting for a network to turn on, right? So instead of it popping up, the log message popping up in the middle of us typing a command, it will pop up at the end after we have executed the command. So exit. So now it says it's required that a minimum of 10 characters be used for all passwords. So security passwords min length. Oops, sorry. So it's 10. Okay, and then we're gonna go ahead and encrypt all the unencrypted password. This command, create a banner that wants anyone accessing the device that unauthorized access is prohibited. Banner MOTD. Configure and enable all the Gigabit Ethernet interfaces. So, okay, let's go ahead and pull up our document. All right. So we need only the Gigabit. So at 01, we don't need that. Because G00, obviously IP address 192.168.0.1.255.255.255, and since it's a /25, it's going to be .128. So go ahead and do that. Now shut it. show IPv6 route. Okay, looks like IPv6 routing is enabled, but we'll just do it just in case. IPv6 unicast routing. Let's go ahead and enable that. G00. Okay, so we just assigned the IP address. Let's go ahead and IPv6 address here. IPv6 address 2001 db8 acat :1/64 IPv6 address fe80 :1 link local. All right. So now it is no shut already, so let's go ahead and move on to interface G01 here. So IP address is going to be 192.168.0.129 255.255.255, and this isn't say /26 is going to be 192. No shut. Okay, no shut that, and then IPv6 address is going to be 2001 db8 acat :1/64 IPv6 address fe80 :1 link local. Coolio. Interface G02 IP address 192.168.0.193. Oh, forgot the subnet masks. 255.255.255.224. No, 220. Oh my gosh, 224. There you go. IPv6 address 2001 db8 acat :1/64 fe80 IPv6 address fe80 :1 link local. Cool. So now we've configured that as well. Alright, so we've configured IPv4. Now it's time for configuring the SSH. Alright, so let's exit that. IP domain. Oh. Yeah. IP domain thing. Sorry about that, guys. Hold up. IP domain name. What is it? CCNA web. Okay, perfect. Let's go ahead and generate the crypto key generate RSA, and that will be a 1024 bit key. Right. Perfect. Configure VTY line, so line VTY 0 to 15. Let's actually hold up. PSSH version 2, and then we'll do let's use version 2. Let's do use local user profiles for authentication. Okay, that's cool. Login local, right? Okay. local. Okay, so then user. Yeah, we'll need to exit this username. What is it? Admin1 password. And just to kind of demonstrate this to you guys, remember how I set the minimum character for the password as 10. So for example, this password not configured. Password is too short. Must be at least 10 characters. So you can see. So admin1 PA5. Now we went through. Configure the console and V2Y lines to log out after 5 minutes of inactivity. Okay, cool. Line VTY 0 to 15, exec timeout, and then we will do 5 minutes. It says 5 minutes. Alrighty, and also it tells us to block anyone for 3 minutes. So log in, block. What's going on? Log in. Huh. Hold up. Hold up. Login. Block. What is going on? Yeah. Let me. That is the command though. I am not sure what is going on. Oh, now I know. I need to exit this. And then also let's do line console 0. Exec timeout. It said how many minutes? 5 minutes. And then exit that. And then this is actually going to be login block 4. Okay, now it works. 3 minutes, 60 times 3 is what? 180. So 180 seconds. Attempts 4 attempts. Within within 2 minutes period, right? So 120. That should do it. Okay, now we have configured the switch, so let's go ahead and actually configure. We've configured router. Let's go ahead and configure the switch. Switches, I should say. Let's see here. And for that, actually, what I'm going to do, I'm going to use a lazy method. So now temp. So enable conf hostname S1. Configure the default gateway. So for S1, the default gateway is going to be, I think it's IP default gateway 192.168.0.1. Get that out privilege mode password. Okay, so enable secret Cisco ENPA 55. Then line 0. And I'm going to come back to this in a little bit here. So line console 0. Line console 0. Password Cisco co-NPA 55. Login. Exit. Oh. Let's go ahead and do exec timeout 5 line TY 0 15 exec timeout 5. Oh, exec timeout 5, yeah. Exec timeout 5. And we'll exit this and then do service password encryption. And let's go ahead and now interface VLAN1 configure the IP address for VLAN1 on S1. So it's going to be IP address 192.168.02. 255.128, right, since it's a /25 network. And we'll do no shift, and that should be it actually. Let's go ahead and just check it. Ipv4 gateway. This should be it. Yep. Alright, so let's go ahead and run this on here. Looks like everything went through just fine. Let's do show run. Alright. Cool. Cool. Alright, it works. So let's go ahead and close that out. Now we're gonna literally just use the same script, right? And just change a few things up, and the default gateway for this one, for switch 2, that's going to be 129. Same thing. It's gonna be 130. And yes, so that should be good. That should be good. Oh wait, what am I doing? Sorry. So this should be 130, and this one should be, let's say /26, so 192. Okay, so now this should be good. So let's go ahead and copy this here. Paste this right in. Looks pretty good to me. Let's go ahead and show exit 5, perfect. Line UI, exit, okay. As you can see, yeah, cool. Encrypted, everything. Hostname, IP domain lookup. Yeah, looks cool. Alright. let's do S3 now. So let's go back up here, change that to S3. The IPv4 gateway for S3 is going to be 183. And this is going to be the same. This is going to be 194. And this is going to be 224. So, yes, we can go ahead and run this. Okay, cool. So now we've configured the switches. Nice. All right. So, connectivity. What are we missing? We'll figure it out. Not sure what we're missing here. Okay. All right. Let's go ahead and see. Let's see. www.cisco.pka. Can get there. Let's go 6 pka. Let's go. Okay, we got to Cisco 6 pk. Perfect. Let's do the same thing here. Cisco.pka. Okay, I can get through that. Cisco 6.pka. Okay, cool. Oh, what is going on? Why is 02? What is the password? Cisco co AMPA 55, isn't it? Yeah. Cisco AMPA 55. Perfect. Show IP interface brief. Did I not? Yeah, that was my bad. Interface G02. Oh shit. Alright. Perfect. So now let's go ahead and see what to do here. PK. Okay. Cisco 6 PK. Let's go. Okay. Cool. But what is actually going on though? Like, why are we sitting at 98% here? I bet we'll find out right now. Let's go ahead and bring our ping prompt. So let's go ahead and ping 192.168.0.190. Okay, it's going over to that subnet. About 222 works just fine. Okay, interesting. Let's go ahead. I mean, obviously we can ping our default gateway since the ping is going through to all the subnets, so we don't have to try that. Obviously it's going through to the PKA because we just pulled up the addresses. Okay. And obviously from the sales to staff, the pings are going because we're getting a reply. But I mean, nevertheless, let's just go ahead and ping 192.168.0.126, I believe that is. Yes. Oh, yeah, it's going through. And it's going to be 222. Yeah, it's going through as well. Yeah. Cool. What about from here? Hold up. From here to ping. Let's ping from here. We'll ping 192.168.0.126. Yeah, going through. And then we're gonna ping 190. Going through. Okay, not sure what is the problem here, so let's go ahead and check the results. Username, wait. Oh, okay. That is an easy fix, my friends. Let's go ahead and it says username is not correct. Alright, let's go ahead and check that. Show run section username. But how is it not correct? Admin1. Admin1. Password. Oh, yeah. Alright. Let's go ahead and get rid of this guy right here. Now, paste. It's an encrypted guy. Never mind. Hold on. My username admin. Let's go ahead and see if it shows up. Okay, it doesn't show up. Computer T. Show run. Username admin1 privilege 15 password or secret, I should say. Admin1 PA55. Okay, got that. Okay, so interface v2y 0 to 15. Oh, no, sorry. Line v2y 0 to 15. Transport input SSH. I think it wants. Yes. Cool. Alright, so transport input SSH, pretty much what it does is it specifically tells the line v2y's to use SSH as the transfer protocol, and I should have I don't know why I didn't capitalize on that, but yeah, so that is what it is supposed to be. Transfer input SSH, because otherwise it will have both the telnet and SSH as remote connection protocols. And yeah, we're done. So thank you so much for joining, y'all. I hope it was a educational video somewhat. Go ahead and like this video if this was useful for you, or You can also go ahead and dislike it if you thought it was boring, it wasn't useful. That's totally fine. And yeah, if you could also go ahead and subscribe if you enjoy my channel. I'll be posting a lot more videos. I have a lot more ideas for this channel, but unfortunately I won't be able to implement them till I'm done with my CCNA, which is going to be pretty soon. So yeah, thank you so much for joining, y'all, and peace be upon all of you, and have a good day.